Somewhere past the last warmth of the sun, a small metal traveler drifts in silence. No engine hums, no voice calls out. Only the faint, patient hum of instruments still counting. Farther from Earth than anything humanity has ever made. It was launched in the 1970s, before smartphones, before modern computers, before the internet was part of daily life. Its mission was supposed to be simple: fly past Jupiter, study Saturn, send data home. But this machine did something no spacecraft had ever done. It kept going, past the giant planets, past the edge of the solar wind, past the invisible line where the sun's influence fades into interstellar dark. And today, almost half a century later, it is still out there, carrying a golden record filled with images, sounds, and voices from Earth. This is not just a spacecraft. It is a message, still traveling. So what makes this machine so impossible? Voyager 1 launched on September 5th, 1977. But this was not just another rocket launch. It was sent into a rare window in time, a special alignment of the outer planets. Jupiter, Saturn, Uranus, and Neptune lined up in a way that let a spacecraft use their gravity like a cosmic slingshot. This maneuver is called a gravity assist. Instead of relying only on its own fuel, Voyager could pass close to each planet, steal a little of its momentum, and get thrown farther and faster. Without it, a journey through the outer solar system would have taken decades longer, if it were possible at all. But from the very beginning, this was more than a technical mission. Bolted to the spacecraft was the golden record, a gold-plated copper disc carrying images, sounds, music, and greetings from Earth. Ocean waves, heartbeats, voices in dozens of languages, even a map showing whoever might find it exactly where this message came from. It was built to collect data, but it was also built to say something about us. Powering all of it were 3 small generators, converting the slow decay of plutonium into a steady trickle of electricity. No solar panels, because past Jupiter, sunlight is too weak to matter. That trickle was never meant to last 50 years. It was meant to last long enough to finish the job. Everything after that would be a bonus nobody had planned for, and its first real test was waiting at Jupiter. When Voyager reached Jupiter, the numbers on paper turned into something nobody expected. From Earth, Jupiter had always been the giant of the solar system, a gas planet larger than every other planet combined. But up close, Jupiter wasn't just huge, it was violent. The cameras caught storms the size of continents, cloud bands tearing past each other, and the Great Red Spot, a vortex wide enough to swallow Earth 3 times over. Winds tore through the atmosphere at speeds no storm on our planet comes close to. And wrapped around it all, a magnetosphere so powerful it could fry unshielded electronics in hours. But the biggest surprise didn't come from the planet at all. It came from one of its moons. On Io, Voyager's cameras caught something no one was looking for: active volcanoes, plumes rising 100 kilometers into space. For the first time, humans were watching eruptions happen on another world in real time. That single image rewrote what scientists thought they knew. The outer solar system wasn't supposed to be alive, too far from the sun, too cold, too dead. But here was a moon burning from the inside out. Jupiter gave Voyager one more thing before letting it go: a slingshot. The spacecraft swung past, stole a fraction of the planet's momentum, and shot outward, faster than it arrived, aimed straight at Saturn. From a distance, Saturn looked almost too perfect. A gas giant wrapped in bright, calm rings, the kind of image you'd expect on a postcard, not a scientific instrument. Up close, that illusion fell apart. The rings weren't a smooth band at all. They were thousands of ringlets, gaps, waves, and braided threads, shaped by the gravity of moons too small to see from Earth. What looked like one simple structure was actually a slow, violent negotiation between ice, dust, and gravity, still playing out. But the real target was Titan, a moon larger than Mercury, wrapped in a nitrogen atmosphere so thick it hides the surface completely. Surface pressure there is higher than on Earth. Beneath the orange haze, scientists suspected a strange chemistry: methane rain, hydrocarbon lakes, molecules building into something almost organic. Voyager flew close enough to study it, But that flyby had a price. The pass through Titan's gravity bent Voyager's path out of the plane of the planets entirely. It meant no Uranus, no Neptune. The mission that could have visited every giant planet in the solar system would only see two. In exchange, it gained a new trajectory, one that would carry it completely out of the solar system forever. Before the cameras were shut off for good, there was one last thing to do. By 1990, the major flybys were long over. Voyager was just a fading signal, moving farther from home with every second. Then, for no scientific reason anyone insisted on, it turned around. From nearly 6 billion kilometers away, it looked back, past Saturn, past Jupiter, toward the inner solar system, toward home, and it took a picture. In that image, Earth isn't a blue ocean world. It isn't clouds or coastlines or anything we'd recognize. It's a single pixel caught in a stray beam of sunlight, a pale blue dot, barely visible at all. Every war, every love story, every person who ever lived, compressed into less light than a speck of dust catches. After that, the cameras went dark to save power. Voyager had shown us giants. Its last picture showed us how small we are. Then it kept moving, toward a boundary no human-made object had ever crossed. For decades, Voyager pushed on, silent, slow from our point of view, but faster than any aircraft or rocket humans had ever built. Ahead of it, the heliopause, the place where the solar wind finally runs out of strength, where the sun's protective bubble ends and true interstellar space begins. On August 25, 2012, it crossed that line. For the first time, something built by human hands had crossed beyond the sun's protective bubble. A signal from Voyager now takes almost a full day to reach us. No live control, no quick corrections, just faint packets of data crawling across billions of kilometers of dark. It had stopped being a mission a long time ago. It had become an outpost, humanity's farthest flung piece of infrastructure, quietly reporting back from outside our own star's front door. Today, it is farther from Earth than anything else we've ever made, and its power is fading. One instrument after another goes dark to save what little energy remains. Sometime in the 2030s, the last signal will likely arrive, and after that, nothing. No dramatic ending. It will simply stop answering, but it won't stop moving. In about 40,000 years, it will drift within a light year and a half of a star called Gliese 445, closer to that sun than to ours, and no one will be listening. The engineers who built it will be forgotten. The country that launched it may not exist. Earth itself may look nothing like it does now. And still, Voyager will keep going. Long after the last radio operator forgets its frequency. Long after the sun itself begins to change. Carrying a record that says, in sounds and images in a language no one out there has ever heard, someone was here, and they looked up, and they tried to say hello. By then, the story of who launched it and why will have long since dissolved into whatever history survives that far, if anything does. There will be no ceremony, no anniversary, no one counting the years since a small team in California watched a rocket lift off a Florida launch pad. Just a piece of metal, older than any nation, older than any language spoken today, still carrying its message forward into a silence that never ends. It may be the loneliest machine humanity has ever built, but it carries the loudest message we've ever sent into the dark.